Hello, today we're discussing related rates in our tutorial, so let's get started. Okay, we have a question to help us get thinking about this, and we're going to compare circles. What happens when you double, or if you triple the radius of a circle, then how does that impact the area? So we have one rate that's changing, which is the radius. The other one is changing is the area. And are they changing at the same rate or different rates? That's what we want to know. So if we look at a circle that has radius r, then its area is pi r squared. If we double that radius, we get 2r, and then its area is pi times 2r squared. But we can see that when we simplify that, the 2 gets squared, and we get 4 pi r squared. So what this illustrates is that by doubling the radius, we end up with a circle that has 4 times the area of the original. Okay, so doubling, and that means we're getting 4 times the area. So the rates are related. Increasing the radius increases the area, but they're not increasing at the same rate. Similarly, if we triple the radius, then we get pi times 3r squared, and then we end up with a circle that is 9 times as large. So this is going up in a squared relationship. We have a 1, 4, 9, next one would be 16. So the rates are related, but they aren't the same. And that's why they're called related rates and not equivalent rates. Okay, let's get into a little bit of notation, and then we're going to do a couple of examples together. Okay, so first thing about notation is we want to try to pick information out of our story problems. These are almost always contextualized on the AP test. And so what we're looking at is if we have something like a height, that's a static number. Your height in the example isn't changing necessarily, so that's what it is. But if we were talking about a change in height, that's a rate of change. That means it's going to be a derivative. And they're almost always with respect to time. If your grade was changing over time, dg, dt, that's how the grade is changing over time. So let's apply it. Okay, we're going to look at a problem with balloons, where we're blowing up balloons for a party. As we put in air, balloon grows, the radius changes, and the volume changes. Are they changing at the same rate or different rates? Let's see. It's kind of like that problem with the circles. Circles growing, how's that changing the area? Same thing here, changing the radius, but how does it change the volume if we consider them to be spheres? Okay, for this example. Okay, so here's what we know. We know the volume is increasing at a rate of 100 cubic centimeters per second. Here's how we want to write that. 100 cubic centimeters per second. That's a rate of change. What's changing? Well, that would be the volume. So this is dV dt. Let's keep going. At what rate is the radius of the balloon increasing? Stop. That's the question. Let's write that down. Okay, the rate of change of the radius, that would be dr dt. When the diameter is 20 centimeters. Now, that's already radius, so I want to write this down as radius. I'm going to write radius equals 10 centimeters. Okay, so there's my setup. Now, we said that this was going to be a sphere, so normally you have to have some sort of additional equation. And knowing that it's a sphere, the thing that jumps out at me is I know the volume of a sphere is 4/3 pi r cubed. And so I want to start with that. Okay, so let's consider what we have. We've got volume here, but that's a rate of change of volume. We have radius here, but that's a rate of change of radius. So what that tells me is that I don't need this equation, I need the derivative of that equation. Now remember, this is an implicit derivative. We're taking these derivatives with respect to time. So v doesn't turn into 1, it turns into dv dt. We've still got our 4/3, we've still got our pi. Remember, the 3 comes down in front with the power rule, and that turns into a 2, so r squared. But be careful, that's r, not x. So it's an implicit derivative, so that means we need to write dr dt right there. And what's nice, now the 3's cancel, let's see what we can substitute into this and figure out if we can answer the objective question. Okay, so plugging in numbers, it looks like dv dt is 100. Equals 4 times pi times r squared. We're told that r is 10, so I'm going to put in 100 because we're squaring it, and then times dr dt. Okay, let's do some solving. Let's do a little bit of division. When I bring all those down, the hundreds cancel out, and I get 1/4 pi equals dr dt. And we're going to leave it right there. The nice folks down at AP do not need you to turn that into a decimal unless the question specifies that you do. Assume that you can leave that just as is. So we're going to call that done. That's our first example. Okay, in our second example, we're moving into more of a standard AP type question. And so in this one, we've got a ladder up against a wall, and that ladder is going to start falling. And they're telling us down here that it's going to move at 1/2 foot per second. That's the rate at which x is going to move away from the wall. Okay, so let's start labeling our picture. Let's start writing down this information. What I want to do, this is OX, and it's moving in the x direction, so I'm going to call this length x. And I'm going to call that length y because it's vertical, and I'm going to call that length z. I want to start labeling this stuff up. Okay? They said the ladder's 15 feet long. That's z, so z is 15. What else do we have? X is moving away at 1/2 foot per second. Now, that doesn't mean x is 1/2, but what it means is that dx dt is 1/2. Okay, let's keep going. Find the rate in feet per second at which the length of OY is changing. OY is there, so that's dy dt. That's what we need to find when x is 9 feet. Cool. So what I'm noticing right now is that we have a right triangle. And that tells me we can employ the Pythagorean theorem. So x squared plus y squared equals z squared. But I've got all these rates. And so that's telling us you need to take a derivative. So let's do that. Okay, what I get when I do that, I get 2x dx dt plus 2y dy dt plus 2, oops, not plus, careful, equals 2z dz dt. And let's start filling in the numbers that we know. Okay, we were told that x is 9. So we get 2 times 9 dx dt is 1/2 plus 2 times y. We need to figure out what y is. Well, look back up at this triangle. Remember your Pythagorean triples. 3, 4, 5 triangle. 6, 8, 10 triangle. Well, another one is the 9, 12, 15 if you just scale that up. Think of it like this. You have a 3, 4, 5 triangle. If you multiply that, make it 3 times as big, that now says 9, 12, 15. Now, if you want to use the Pythagorean theorem to figure that out, go for it. But I'm using this method, so that little guy right there is 12. Y is 12. I'm going to plug that in. dy dt, not going to put that in. That's the quantity that we want to find out. So I'm going to just rewrite dy dt equals 2 times z, that's 15. That's how long the ladder is. And then dz dt. So think about what that would mean. What it's saying is the rate at which the length of the ladder is changing. But there was nothing in the question that told us that the length of the ladder was changing. And because of that, this is 0, which is actually really, really nice, because that's all going to zero out and go away. Let's simplify. We should label that as part A. Let's simplify. So the 2's cancel out, that's 9. And 2 times 12 is 24. 24 dy dt equals 0. This implies that dy dt equals -9 over 24. Okay, and again, okay, some of you are noticing that can simplify. We don't have to. Okay, we can just leave it. It's totally fine. Okay, now we're going to go to part B. Find the rate of change in square feet per second. Okay, square feet per second. They're talking about an area. The area of the triangle. So what I want to start with, I just want to write down the equation for the area of the triangle. And a lot of people will start to go, okay, 1/2 base times height. Okay, well that's not very helpful because we don't have b or h in this. I want to rewrite this in a way that fits our scenario. So that's going to be like this. Area equals 1/2. The base up there was x, and the height was y. And that's going to be much more helpful. Okay? But we need the rate of change. So what are we going to do? Well, it's derivative time. So dA dt, that's the quantity we're after, equals 1/2 a product rule. So that would go like this. dx dt times y plus x times dy dt. Let's start filling in numbers and see what happens. So 1/2 dx dt we know was, let me look up again, dx dt was 1/2. So a half, we get a half there. Y was 12 plus x, that was 9, times dy dt, -9 over 24. And here's the bizarre thing. We are going to leave that alone. Okay? And that's very uncomfortable for a lot of people, including myself, because normally we want like a nice, succinct answer. But the deal is, on the AP exam, what they want to see is that you've got your calculus down. And we've totally demonstrated that here. Our calculus looks great, and they will give you full points for that. If you continue and make an algebraic mistake, though, or an arithmetic mistake, excuse me, they're going to mark you down for that. So let's just leave it. We're good. Okay, and this will be our last one today, and then we'll be done. Okay, this is a really standard test type of question at the college level, at the AP level. Okay, so we have a cone, and the cone is increasing in its size. Sometimes it's an example where you're pouring water into the cone and the depth of the water is changing. This one, the cone is growing. Okay, so the volume is increasing at a rate of 28 cubic units per second. Pause. Volume is increasing. That's a derivative. dV dt equals 28 pi. Let's keep going. At the instant when the radius is 3, r equals 3, the volume is 12 pi. And the radius is increasing, okay, that's a derivative, so dr dt equals 1/2. Awesome, so we've plucked out all the information. I'm just going to box that off for right now, and then we're going to try to answer the question that's asked. Okay? So here's what we got. At the instant when the radius is 3, what's the rate of change of the area of the base? Alright, so on a cone, the base is a circle. And so what I know about circles, area of a circle is area equals pi r squared. Okay, so I'm just taking the information they gave me. They said rate of change of area of the base. That's the area of the base. They asked for a rate of change, which means it's derivative time, so that would be dA dt equals 2 pi r dr dt. And let's see if we can plug numbers into that and see what happens. So, we got 2, we got pi, they told us the radius is 3, and dr dt is 1/2. Now, I just cannot resist the urge to simplify this one. I have to, because it's just going to drive me nuts. Because I got a little 1/2 and a 2, so those go away. And then I can get 3 pi. And I'm going to put units on it, so it's an area unit. They told me it's units, so that would be units squared. And it's a rate over time, and the time unit in this is seconds. So unit squared per second. Okay, that's part A, and part A is all done now. Let's go to B. At the instant when the radius is 3, what's the rate of change of the height? So that tells me that what I'm after is dH dt. And so the way I think about this is I need an equation about a cone that has height in it somewhere. And wouldn't you know, they gave that to us in the question. They gave it right up here. Now, I'm expecting that you will know that one from geometry, and if you don't know it, it's time to get it back and memorize it. 1/3 pi r squared height. So let's play with that for a second. Okay, that looks like a perfectly nice equation. If we took a derivative of it, we could get a dH dt. So that suggests to me that we should probably start taking a derivative. Let's try it. dV dt equals 1/3 pi. Remember, those are constants, and now we've got a product rule. So we get 2r dr dt h plus h, dH dt r squared. Okay, what we've done, we have the derivative of the first part, 2r dr dt, times the original, and then we take the derivative of that one times the original, which is r squared. Okay, let's start plugging stuff in, see what happens. So I'm going to scroll back up here. dV dt, we were told, is 28. Or excuse me, 28 pi. Okay. So we've got that equals 1/3 pi times 2 times the radius, which is 3, times dr dt. Do we know dr dt? We do, 1/2. Times 1/2, times the height. Hey, do we know the height? I'm not sure that we do. That could be a little bit of a problem. We need to actually solve it. I do see an equation here that has height in there, so we actually need to pause. I'm going to color code this as side work, but we need to try that real quick. So we're told the volume is 12 pi, and that should equal 1/3 pi r squared, that's 3 squared, times the height. Let's see what happens when we do that. 1/3 and a 3 cancel out. So now that's not squared anymore. You're going to think that is 9/3 is 3, that's fine. And the pi's cancel out, so you can divide them on both sides. And then we're going to divide by 3, and so we get 4 equals h. Okay, so I'm going to drop that in down here now. Okay, dH dt That's the quantity we're after, so we don't know that yet. So I'm just going to rewrite it, dH dt, and then r squared, that's 3 squared, which is 9. Okay? And then we get that question, do you think you can leave it? I mean, up here we left it alone, or we have the option to leave it alone. You cannot leave this one alone because it has not been solved for dH dt yet. They asked specifically about dH dt, and so we're actually going to have to do that. So let's roll through this and see what happens. First thing I notice is I got pi on both sides. I can divide both sides by pi, and those are gone. And then let's see what other simplifying we can do. These quantities in here are both going to be divided by 3. So what happens when we do that, that's going to cancel out this 3, and this 9 is going to turn into a 3. And let's see what we have. Oh, you know what? I noticed something else. I have right here a 2 and a 1/2. So those cancel out as well. So we've canceled out a bunch of stuff already. Let's rewrite what we have. I have 28 equals 4 plus 3 dH dt. Okay, let's continue. Subtract the 4, you get 24 equals 3 dH dt. Divide by 3, and I get 8 equals dH dt. Okay. Hope you enjoyed the intro to related rates. We're all done. See you next time.